Here we go. We're recording example 2 from lesson 1.1, and we're looking at it as part A here. So right now we are putting this equation into our calculator. We're going to go to the calculator and put in 16 minus 0.05. Y equals here. 16 minus 0.05 x. And sometimes on the graphing calculator, if you just hit graph on a standard window like I'm about to do now, you don't see anything. That's because the window isn't right for the function that we're trying to view. So let's go ahead back to the notes page where we just were. And I like to cheat a little bit and maybe look at how the book has their window set up. Since the book has a scale, it looks like it goes from 0 to 20 on the y-axis, and from 0 to 360, is that? Okay, that should work. So we're going to go to window on the x-axis. Here we go. We're going to go back to the calculator. We'll press window. Here, we're going to make our calculator match the window that the book has. So for the x-min and x-max, we're going to go 0, enter, 360, enter. For y-min, we're going to go 0, y-max, 20. This will set the window up so that we see the graph now. You don't really have to change the scale unless you're kind of a perfectionist and you want it to match what the book had. I typically leave the x scale and the y scale at 1. I really don't mess with it very much. Now when you hit graph, you'll see the graph. So that's good. So we're going to explore and find the y-intercept and the x-intercept. And for that, I'm going to hit trace. For the y-intercept, after pressing the trace button, just enter the number 0, and that'll plug in 0 for x. Hit enter, and it'll give you the y-intercept, 16. You may notice that 16 is in the equation because this is a linear equation. The y-intercept is the constant in the linear equation. So, for the first answer, we have a y-intercept of 0, 16. Y-intercept is 0, 16. And let's find the x-intercept. Now we're going to go to find the x-intercept by going back to the calculator. I suppose we could make some guesses. There are a few ways that you can do this. You could certainly trace and drag the little cursor to the right for a really long time. Like that. That's going to take a while, especially since we're going up to 360 here. You could guess some numbers for x, like how about 300? What we're looking for is the y coordinate to be 0. 300 was a little bit too small. Let's try 360. Oh, we're down in the negatives. The 360 was too large of a guess. 320. Perfect. 320 represents the x-intercept because the y coordinate is 0 at that point. That's one way to do it. Guess and check. Here's another way to do it. Go back to y equals, go down to y2, and just put in the number 0. That's going to make a flat line or a horizontal line on the x-axis when you hit graph. It turned red because on my calculator, y2 is red. Now, instead of guessing and checking, we can use second trace. That's the calculate menu. So second trace gets you to the calculate menu. Option 5 will allow you to find the intersection between the two lines. And this early in the year, when we're only dealing with lines, 2 of them, you can just hit enter, 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 and you're there. The intersection 320, 0. All right, finishing up here, We're going back to example 2, and we're talking about we have 320, comma 0. And what do they represent in this situation? So we're going to take a moment to ask the students. I'm going to pause the video. I'm going to ask the kids what they think. What does 0, comma 16 have to do with the situation? And what does 320, comma 0 have to do with this car's situation? So we have some student volunteers here. Explain that 0, 16 has to do with the range of the function, and it's the capacity of the gas tank. It's how many gallons of gas it holds. Right when you leave the gas station and you fill up, you've done 0 miles and you have 16 gallons. And then another student said that 320 miles, or X, is how long you could drive until you run out of gas. So